So we've got a big agenda today. We want to walk through, and we're going to talk about some of the applications of how the TV Whitespace has been deployed and it's being utilized here in New Hanover County. I want to first of all introduce to you today from the FCC, Alan Stillwell. And Alan is with the Deputy Chief Office of Engineering and Technology at the FCC. He's been involved in this project for a while, and I'm sure he'll talk a little bit about that as well. So Alan, if you could join us, thank you.
Thank you, Rod. If I can get this microphone right here. I first want to say that I'm really grateful for the opportunity to be here with you today as we mark the start of operations in the TV Whitespaces. And I especially want to thank all of the North Carolina elected representatives and other officials who've made time in their busy schedules to be here with us for this important event. This is a project that was, as Rod kind of indicated, developed over a long time, 10 years in fact, and it was no simple matter. We had to do background technical research and learning, policy development, and finally the development of systems and devices for actual operational deployment. Now, successful operation on the TV Whitespace spectrum, which means no interference to broadcast TV and the many other licensed services that operate in those bands, is really not a trivial matter. Getting there has involved the cooperation of many parties, including a lot of broadcast TV licensees. And we at the FCC are really most pleased to see this new service potential being made available to the American public. And I also especially want to thank the city of Wilmington. It's the first city in the nation to transition from analog to digital television. And now you're taking the lead in introducing new technology in this context for broadband to our nation. This is, in fact, as Rod indicated, the first commercial deployment of Whitespace technology in the world. Okay. As our chairman at the FCC, Julius Janikowski, recently stated, the unused spectrum between the TV stations, which we call Whitespaces, or at the Commission Super Wi-Fi, represents a valuable opportunity for provision of broadband data services. In our changing wireless landscape, this resource, the capacity is very important as demand grows. This unused TV spectrum provides a major new platform for innovation and delivery of service on an unlicensed basis. That means it's open to everyone. And it has potential for both research and commercial applications. So in this context, we see the rollout of Whitespace devices and systems as an important step towards enabling a new wave of wireless innovation. Opening up the Whitespace spectrum has potential to exceed even the many billions of dollars in economic benefits we've realized from Wi-Fi service, thereby driving both investments and opportunities for job creation. This same technology holds promise for making more efficient use of other parts of the spectrum as well, as we help to meet growing demand for broadband wireless communications. In other words, this is one area where there's white space. There are other spectrum areas where there are white spaces also. So we'll start here, and we'll see if we can maybe extend this concept to other bands. So in the broadband context, the Whitespace project is an important part of the Commission's National Broadband Plan. And in that plan, the Commission set out a comprehensive strategy for developing a world-leading broadband ecosystem for the United States. This plan is comprehensive from infrastructure to applications, and it's intended to ensure a strategic bandwidth advantage for our country. And the plan has 4 bandwidth-related goals I'd like to go through just briefly. First, we need ubiquitous broadband access so that we have the most attractive market in the world for high-speed broadband applications and services. This will maximize incentives for innovators and entrepreneurs to develop and launch products here while exporting to the rest of the world. Second, we need to unleash spectrum so that mobile broadband can achieve its vast potential in driving economic growth and job creation. we need to address the looming spectrum crunch, and we also need to ensure the availability of unlicensed spectrum as a part of that for a platform for American innovation. Third, we need broadband innovation zones to fuel U.S. leadership in broadband applications, services, and products. These zones would be geographic areas where entrepreneurs and innovators can try out new ideas. These ultra high-speed test beds can eliminate bandwidth as a constraint on innovation and give America's great innovators and entrepreneurs a destination for experimentation and invention. The fourth goal is to provide for universal broadband adoption so that every American is taking advantage of our 21st century, now it's not 20th anymore, 21st century communications platform for finding and landing jobs, for connecting in education in and out of the classroom, and for obtaining healthcare information, diagnosis, and sometimes even treatment, and for participating in your community. Right now, 1/3 of our population doesn't have broadband at home. That's 100 million Americans who are held back by issues that include cost, lack of digital literacy, and an underappreciation for the value of broadband access. And so at the FCC, we're trying to use all the levers at our disposal to deliver on these strategic goals. So where's the white space fit into this? Well, opening up the TV white spaces will serve the Commission's goals for broadband by providing a means for local connectivity to the network, as Rob was kind of indicating there. The products and services to be provided on this spectrum will promote economic growth in both technology and jobs. Now, other nations are also expecting spectrum shortages, and it's the same as we are here in the U.S., and so there's considerable interest worldwide in use of white space spectrum. That's in the TV bands and in other bands. And we're clearly in the lead in this field. In the, the 2 trials of our TV white space database systems conducted thus far have seen participation by people in more than 27 countries. So people from the outside are coming in and accessing our trials to see how this is working and see how well we're doing. The applications that are starting here today in Wilmington, as I said earlier, are the first actual operations of wireless services using this white space technology and spectrum. So now that I've talked about what our broadband goals are and how white space authorization fits into it, you're probably wondering, well, what is this technology and what can it be used for? Now Rod went through some of it, and I think I'll just kind of fill in a few more holes. First of all, in the frequency bands used by broadcast television, white space is a geographic area where there are no TV or other licensed radio services in operation on the TV channel. So this unused spectrum is a place where if you operate a small low-power transmitter, you won't interfere with something else. So there's an opportunity there then to operate another radio service. And at any given location, there's a lot of channels where no stations are providing service. And so as Rod said, we have this, like here in Wilmington, we have a tremendous resource that's available to us, about twice as much as we have for Wi-Fi. So now if you take and plot the service areas of licensed TV and other radio services on a map, you'll kind of have, you know, the areas where interference would occur, and then if you color in those areas, the areas that were spectrum unused, that area is white, and needing a shorthand name for this project, because of that we ended up calling this white spaces, and that the name stuck. So the challenge here really is to identify white space so that you don't cause interference. And the thing is that the channels available vary by specific locations. So if you're on the north side of town, the channels that are used already will differ from the channels that are, say, on the south side of town. And sometimes within a market, in many different places. So it's not like you can say, well, In Wilmington, all of these channels are available. There's some parts of Wilmington, some channels are available. Other parts, other channels will be available. So to deal with this, we came up with this groundbreaking approach. And that's a database, as Rod said. This database keeps track of all the white space. It knows where all the TV stations and other stations are. And I keep saying other stations, it's TV bands, but there are public safety services there. There are radio astronomy receive services there. There's all kinds of things in the TV spectrum that actually, when we started this project, we weren't really that aware of. And that's one of the things we learned, is how many different kinds of things share these bands. And the database keeps track of all this, and at any given location, it can calculate what channels are available. And the Whitespace devices, they have a geolocation capability. For a lot of devices, it's typically a GPS. And so the device transmits its location to the database. The database takes that location, determines the available channel there, and then sends it back to the device, and the device operates on those channels. So that's the scheme. In principle, it seems pretty easy. It took us a long time to get here. So now, as far as applications go, we expect the major use will be for broadband data communications. In many respects similar to Wi-Fi, but with some important differences due to the propagation differences between the two bands. Let's see. We think that Whitespace devices will be suitable to serve areas on the size order of, say, schools and business campuses, and in rural locations. For example, you can put a Whitespace device on a utility pole, and then if you have a home or a business that are some distance off the road, you can reach that location from the road, okay? Whitespaces will also support better connections inside your home. If you have internet service in your home and you're having a problem getting from one end of the house to the other, the super Wi-Fi device may solve a lot of those problems for you. So in addition to the basic internet connectivity of the super Wi-Fi concept, the folks who have been looking at Wi-Fi device design have suggested a wide variety of different types of applications that these systems could serve. And the list is long. It's even longer than my arm. I don't have the longest arm, but it's a long list, I'll tell you that. And, as is typical of almost all new spectrum use concepts and technical opportunities, it's likely that some of these ideas for new products and services will succeed and others won't. And the market sorts these kinds of things out. It always has and it always will, and that's the best system really for achieving, that kind of determination in our economy. So, if you compare it to Wi-Fi, Wi-Fi started out as a spread spectrum concept. The spread spectrum concept didn't work too well, and it evolved into Wi-Fi 12 years later, which was then successful. So now I won't go through this whole list with you, but I'd just like to give you an overview of a few of these other kinds of applications. First is network deployment. And as Rod says, because the signals in the TV bands can not only be received farther away, but they can penetrate things like foliage, they get through the weather, and and to some extent buildings. I think will have better service capabilities around locations. These systems can provide coverage for local community-based wireless networks, improve opportunities for delivering broadcast service to unserved areas, and things like that. Another application's education and enterprise video conferencing, where Whitespace systems provide college campuses and local schools with new multimedia capabilities for use in classrooms. There are smart city networks. Cities and communities often have communications needs that could be met through short-range communication facilities. And we're seeing some of this here in Wilmington in terms of this Whitespace applications being used to monitor water supplies. So, and this same technology could also be used for healthcare and smart grid applications. Smart grid are systems for controlling the electric power grid. There are digital video systems. The wide bandwidths here could be used for better delivery of video systems in the home. We use Wi-Fi for that now. I think this, if you want, somebody's watching video in your house and somebody else wants to use a computer, you won't have that contention there. The kids are watching video and you have to pay the bills. And then consumer devices. Our homes really are becoming network hubs for all sorts of electronic devices. We have computers, laptops, tablets, PDAs, cameras, TVs, Blu-ray players, cameras, well, you can go on and on because we all have these things and use them. In closing, I want to thank and recognize Spectrum Bridge and its team who've worked so hard to get their database system up and operational. We have other database systems here in our, I think Telcordia is also pretty close to bringing its system up. And also want to thank the City of Wilmington and its government decision makers for stepping up really and embracing this technical innovation and communication services. Not only has the city undertaken this initial step for Whitespace, but we at the FCC also remember how the city was really the first to step up and take the major step of turning off its analog TV service several years ago in the digital TV transition. What we learned here in Wilmington in that trial really helped us with our nationwide rollout. So we at the FCC, we really appreciate your commitment and strong support for introduction of advancements and innovations in wireless communications. And I thank you very much. Thank you.